Hello, everyone. Today, I'm going to present my learnings from 6 research papers where I tried to understand machine learning based cyber attacks. In recent times, with increased interaction with numerous electronic devices, we are experiencing many newest cyber attacks where our data is being used against us while we interact with these different kinds of devices. It became highly important to make use of machine learning models and algorithms to identify the patterns and learn from them in order to avoid these kinds of cyber attacks. So in this presentation, I am going to dive into understanding 6 different papers. We'll start by exploring the intent behind phishing. Then we will move to understand a tool to manage online advertising called Harpo. Later, we will have a comprehensive look into how the author proposed a model to eliminate redundant or abusive traffic from the internet. Next, we'll examine the author's deepfake profile creation model to see how social media users react and get manipulated by these fake social models. Then we'll look into how DNNs are disrupted using adversarial examples which fool the autonomous vehicles. And lastly, we will move to infer why it is important to safeguard and copyright DNNs. So the first paper that I'm going to talk about is inferring phishing intention via web page appearance and dynamics. This is based on a deep vision based approach. We might have been prone to get phished online many times. Take a close look at this website. It is not a PayPal account, but trying to look like one. But the website URL is not a PayPal URL. So phishing is an attack to compromise privacy with a set of social engineering tricks. An attacker will create a faking website with a similar experience to a legitimate website, just like this screenshot. And it has been reported that this kind of attacks rose by 63% in the year 2021 and going to rise in the coming years. So there are many industry solutions that are available, which are classification based and blacklist based, like Google Safe Browsing, Fishpedia. But for all those, it will take at least 7 days to update their database. So attackers are quickly creating phishing websites by changing HTML content with very little cost, making existing machine learning based models obsolete, which are heavily designed based on HTML methods. So in order to overcome this problem, the authors came up with a reference based solution, which is this inferring phishing intention. Which will get rid of HTML code analysis. So phishing intention looks into screenshots by utilizing computer vision techniques to detect both credential taking intention and brand intention. It is a comprehensive intention based solution using static and dynamic web page analysis to detect the intention. So the approach is through web page representation extraction, which is using the AWL, the web page screenshot will be looked for where a particular UI element is there, where the location and shape of the most salient UI elements are extracted, like the logos, buttons, inputs, labels, and blocks. Next, they will look for branding intention identification. So once they get these details, then the logo is compared with the brand reference list to identify the brand intention. While doing this, a metrical learning approach is used to compare the similarity of two logos. Then they will move to credential taking intention, where they take a binary classification model. In order to do this, a 0 is assigned for non-credential taking intention and a 1 is assigned for a credential taking intention. So credential taking intention confirmation they'll do by object detection techniques to further detect which region on the screenshot might lead to another credential taking web page. So in order to evaluate the performance of phishing intention, they have conducted many experiments like phishing detection experiment, CRP location experiment, evaluating model-wise performance, robustness against adversaries, phishing discovery experiment. So especially the phishing discovery experiment, the authors are using a web crawling system to report the zero-day phishing websites. Each web page will be passed to 5 reference-based web page sites like Fishpedia, Phish Intention, Visual Phishnet, PhishU, EMD. If it is identified as a phishing website, a Telegram service is used to send it across to participant users who will manually evaluate if it is a real phish. After 2 months of running the survey, Phish Intention has reportedly generated like identified 1942 real phishing web pages, out of which 1368 are zero-day phishing. The limitations for this is there is no link between brand intention and credential taking intention, which might lead to false positives or false negatives. When there are QR codes, this approach will not work. Next, we are going to discuss about Harpo, which is a model which is trying to learn how to subvert online behavioral advertising. When we observe online, it is quite common to find many advertisements targeting us, and no wonder they are analyzing all the data that we are using. A lot of times it is quite easy to identify trends and patterns using machine learning models. Online behavioral advertising is what is causing all the crazy pop-ups that we are seeing like while we are online. In order to do this, there is a lot of privacy invasive tracking that's happening. Many techniques are used for user profiling and subsequent targeting, which is posing a threat to our privacy. So, here in this paper, the author has proposed a model that helps in achieving online privacy through subverting the online behavioral advertising. There are many existing privacy techniques like privacy by design, which can be typically used in iOS. We have even blocking, like ad blocking, which is a defensive style of privacy preserving technique. It can even kill the advertising ecosystem. And lastly, we have obfuscation, which is offensive and more advertising ecosystem friendly, but they are not as effective as they should be in the real world. So here the author is using the threat model where the user and the tracker are simulated. The obfuscator that they are using should be seamless, stealthy, and having low overhead. There are two real world tracking models that they have used, which is the user profiling model and the ad targeting model. As per the proposed approach, Harpo interlinks the user web pages visits with obfuscation web page visits. It takes extra content features of web pages, privacy metrics have been used for calculating the percentiles of false negatives. In terms of system model, obfuscation URL selection process is working as a markup decision process. The system is designed in this way. Content feature extraction, which has doc to embedding, RL agent model via CNN, surrogate model, which will replicate the real world user profile, URL agent, where they have used the Harpo browser extension. In terms of experiments, they have constructed 25,000 online user personas to replicate the user personal data. Data has been collected from interest segments, bits, data collection. The accuracy of surrogate models is 96.57% true positive with 20 user profiles. The evaluation process provides results showcasing that the Harpo model has higher privacy, obfuscation overhead, which is having minimum impact on user experience change. It has high stealthiness and the personalization is also high. So it has been observed that Harpo models gives better performance than other available models that are there in the market. Next, we are going to discuss about deepish. So while being a part of social networks, we will come across many fake profiles on almost all social media platforms, and most of these use deepfake techniques, which make it extremely difficult to understand which profile should be trusted. Here in this paper, the author is trying to understand the user's trust towards these kind of artificially generated profiles in online social networks. So how can we differentiate a deep fake profile? So for which author has provided 5 profile artifact conditions, which you can see in this image, where one among this is consistent profile condition and the remaining 4 conditions are intra field, where they look for image artifacts, intra field where they have text artifacts, interfield where they have image artifacts and text artifacts. So here the author has conducted research by constructing the social profile using StyleGang model. This is one of the popular fake profile generative modes. The fundamental building components that are utilized to create profiles is what you are seeing. The parameters that are considered for experiments are perceived powerful trustworthiness, profile acceptance, comparing different artifacts, profile assessment reasoning, and unexpected perceptions of artifacts. The author created the profile with a high volume of image pool consisting of 3 sets of the pool, each containing 15 male and female users. The author has conducted the test with 256 participants to see how they are reacting or responding to the fake artifacts generated by the author. Interestingly, under almost all prompted situations, people have interacted with these profiles, and the trust score that they have assigned for these profiles is quite high. Almost half of the participants has given 60 to 70%, indicating that the majority of contestants have confidence in deepfake profiles. The countermeasures that we can use in order to save ourselves from these kind of deepfake profiles are community-based moderation and empirical measurements of deepfake profiles. The limitations for this is the participants that they have taken in this survey are from MTruck, which might lead to bias. So the way how the role playing methodology has been implemented. The survey is only conducted only on LinkedIn. The focus is heavily based on perceived profile trustworthiness. Next, we are going to talk about automated detection of automatic traffic. In this paper, the author is trying to find a method to separate abuse from legitimate traffic in a web server. So in a web server, we have both human traffic and bot traffic. The limitation is that we have to find such bot traffic is that They don't have any labels attached to them to use any of the machine learning models, as most of the data is in form of strings but not in numericals. So here the author is trying to come up with a method that tackles situations where we are having at least 50% of transmission is abusive. So first the author is calculating clean traffic using this clean distribution algorithm. Then he is providing a mechanism to gauge the probability that a request was created by a bot as opposed to a person on the internet. The author has divided the analysis based on supervised, one sided feature categories, base rate ambiguity, and interpretability categories. Moreover, the author says that there are no tags necessary and the procedure that he has designed is unmonitored. Only the distribution of characteristics in the harmless traffic are attempted to be estimated, which is making it pretty much one sided. Then we are going to talk about how the autonomous vehicles are fooled using adversarial examples and how can we recognize them. So this paper solves the problem of robust physical adversarial examples and real-world object detectors. Adversarial examples can deceive deep neural networks, and many researchers are related to this. But most of them are related to digital domain and static patches, which is very different from DNN in real-world applications, such as in traffic sign recognition. The authors have taken a systematic pipeline to generate robust physical AEs against real world object detectors. Instead of digital AEs, which are being used to perform research on traffic sign recognition, which is TSR systems, which are less effective in real world scenarios, they have simulated inputs utilizing the in-vehicle cameras, designed single and multiple bounding box filters, considered different attack vectors, performed comprehensive set of experiments under a variety of conditions like varying the distance, changing angles, testing these generated physical AEs on devices like vehicles like YOLO V5 based TSR systems, and even came up with the defense mechanisms. So first they extended the distributed image transform with blur transform and resolution transform to simulate a car camera. Then single bounding box and multiple bounding box filter is designed to obtain a relatively pre-physical AE box. They have defined four loss functions to train the corresponding adversarial perturbations to follow four attack vectors, which is like hidden attack, then appearance attack, non-target attack, and target attack. To improve the transferability of AE, they also use different background images in the AE generation algorithm to avoid overfitting. So all these attacks are successful in fooling the traffic recognition system, which could be a life-threatening case for autonomous vehicles, which needs to be worked on. Then the last paper that I'm going to talk about is why it is important to copyright DNN models. So as we know, deep learning models, especially those large scale and high performing ones, can be very costly to train, demanding a considerable amount of data and computational resources. As a result, deep learning models have become one of the most valuable assets in modern artificial intelligence. Unauthorized duplication or reproduction of deep learning models can lead to copyright infringement and cause huge economic losses to model owners, calling for effective copyright protection techniques. Existing protection techniques are mostly based on watermarking, which embeds an owner specified watermark into the model. While being able to provide exact ownership verification, these techniques are invasive. They need to tamper with the training process, which may affect the quality and the model utility or introduce new security risks into the model. These are prone to adaptive attacks that attempt to remove or replace the watermark or adversarially block the retrieval of the watermark. And the next problem is not robust to the emerging model extraction techniques. Latest fingerprinting works on deep learning models, though being non-invasive also falls short when facing the diverse and ever-growing attack scenarios. So in this, we are trying to understand the testing framework which has been given for doing the copyright protection, which is the deep judge testing framework, as you can see here. So this quantitatively tests the similarities between two deep learning models, a victim model and a suspect model. So here the model is leveraging a diverse set of testing metrics, where the test case generation you can see here. So they are generating a testing diverse set of testing metrics and efficient test case generation algorithms to produce a chain of supporting evidence to help determine whether a suspect model is a copy of the victim model or not. The advantages of deep judge include it being non-invasive, as it works directly on the model and does not tamper with the training process like remaining ones. Efficient, as it only needs a small set of seed test cases and a quick scan of the two models. Flexible, as it can easily incorporate new testing metrics or test case generation methods to obtain more confident and robust judgment, fairly robust to model extraction attacks and adaptive attacks. We verify the effectiveness of deep judge under three typical copyright infringement scenarios, including model fine tuning, pruning, and extraction via extensive experiments on both image classification and speech recognition datasets with a variety of model architecture. So these are the papers that I have used for referring. And yeah, thank you.